Welcome to another A-Level Computer Science video with me, Mr Goff, for MrGoff.com. This video will focus on function application. The process of giving particular inputs to a function is called function application. For example, add34 represents the application of the function add to the integer arguments 3 and 4. The type of the function is integer cross integer maps to integer, where integer cross integer is the Cartesian product of the set integer with itself. Although we would say that the function f takes 2 arguments, in fact it takes only 1 argument, which is a pair, for example, the tuple 3, 4. We can define functions in Haskell and apply the function to specific arguments and have the result returned. Here in this example, you can see I've defined a function add xy that will add the 2 values x and y passed to it. I've then applied it to the integers 3, 4 and to the floats 3.0 and 4.4. Both of these have returned the result of adding the 2 values passed to it. To understand function application, we have to understand how functions are evaluated. Any function only takes 1 argument at a time. The function add takes 2 integers as arguments and gives an integer as a result, but can be viewed as follows in the partial function application scheme. Add takes an integer as input and returns a function that will take an integer as input and return an integer. When we call add34, add3 returns a function which, when applied to 4, adds 3 to 4. The brackets may be dropped, so the function add becomes add integer maps to integer maps to integer. The function add is now viewed as taking 1 argument after another and returning a result of a data type integer. Because functions are evaluated one after the next, we can create functions that take advantage of this through partial function application. For instance, we can create a function add10 using the add function we've already created, add xy, by forcing one of the values to always be 10. We now supply 1 argument and add10 provides the other. The operation functional composition combines 2 functions to get a new function. Given 2 functions, function f with a domain A and codomain B, and function g with a domain B and codomain C, the function GOF, called the composition of G and F, is a function whose domain is A and codomain is C. If the domain and codomains of f and g are the set of real numbers, and the function of x is to add 2 to x, and the function g of y is to multiply y by 3, then the composition of g and f is x plus 2 times 3. F is first applied, and then g is applied to the result returned by f. In simple terms, the result of function f has been passed to function g as an argument. This only works because the codomain of function f matches the domain of function g. Below you can see the result of the function add2 3 is used as an argument for the function times 3. When we pass times 3 add2 3, it first adds 2 to 3 to get 5, and then multiplies 5 by 3 to get 15. That brings us to the end of this video on function application. Join me again soon when I'll be having a closer look at higher order functions. Use the resources at MrGoff.com to help you revise computer science, and until next time, it's bye for now.